a very big thank you to Jeff, Steve, Jennifer, and the team for inviting me today to talk. A little bit about me and my background in my talk today. So currently I'm Chief AI Officer for Public Sector Network and also CEO for Public Sector Consulting. And today I want to talk a little bit about AI and data architecture. And I think what's really important here, throughout my entire presentation, I'm going to talk about the impacts of AI. You may have heard that from Lee and others this morning, I think, as well as Jeff. I think AI has a significant impact in our society today. It's how do we handle the data architecture is going to be absolutely key in the application of AI. We are now in the fourth industrial revolution, and you may have heard this throughout many talks today, where we literally transforming jobs, economies, and society. And we've been through the various studies, various industry revolutions through the 18th century, the 20th century, the 70s with the electronic automation. But today, we notice our fourth industrial revolution where the physical and digital worlds combining through analytics, AI, cognitive technologies, the Internet of Things to create enterprises that are both interconnected and capable of intelligent action. I think the key is intelligent action. We've gone through this entire evolution to date. AI is getting smarter. It's being applied in all areas in our lives today. And we need to take acknowledgement of it and obviously work with it and improve where we are today. I think COVID as well at the same time has really accelerated our digital impact with the application of these technologies. So agenda for today, I'm going to talk a little bit, and not in this specific order, but throughout my talk, I'm going to talk about AI tooling. Why is it important to automate the AI journey? Why no coding is critical, which enables ease of use. I'll then go into the data architecture. I think, data architectures are absolutely key in building precise AI models that's going to impact business today. And I couldn't emphasize more, we talk a lot about the modeling techniques, but ultimately, to feed the AI model and to train it, it's all about the data. And how does this architecture impact our outputs? And I'll talk a little bit about that as we go through. You notice around AI audits and trail available to explain outcomes based on inputs. It's really critical to have an AI trail or an audit trail to actually explain how you've came about with your predictions. That's going to be absolutely key. You've heard about the impact of algorithm ethics, how to remove bias. These are important aspects. And all of these today all comes down to one thing. It's how do you feed and train your models to get you those accurate predictions? And if you've done your best in the training process, we normally can remove our bias and also look at how we impact ethics. And we'll talk a little bit about that through our data architecture. I think it's really important to tell your story as well. If we're going through this AI journey, you need to understand what the data inputs are going to be, and it comes down to your architecture. And then how do you explain your outputs? Going to be absolutely critical, and how to deal with large volumes of data, which is very important in terms of your training process. So why is AI important today? We need to understand the application of AI to business functions and how we calibrate our thinking to look at the benefits of AI. To implement AI, we obviously need a good data governance framework and improved data practices, whether it's in government or in business today. It's really critical to have that framework. And how do we think about AI? We need to develop an AI strategy that embraces the thinking associated with the application of AI to government and business today. What are some of the outputs you expect from such a strategy? Some of the use cases, the risk mitigation around bias and impacts to human rights, and the explainability of AI modeling. Obviously, when you are talking to business today, whether you're a student or a business leader, it's really important to talk about the impacts of AI, and what are these impacts going to be from a budgeting, from an outcome perspective. Having the core team to deliver your AI and use cases are going to be really important. And are we looking at an AI framework that we can execute? So the inputs will always give you similar outputs, and it's repeatable. So if I take the same data set and remodel it again, am I going to get my same outputs consistently? We know that AI today is a combination of these various aspects. So what is AI? We started off with statistics, from linear regression to logistic regression, and then we moved on to machine learning, where we evolved into random forest and gradient boosted machines. And today we have deep learning, which is our neural nets and our reinforcement learning. And I think a lot of the aspects, or today a modeling, is focusing on deep learning for many reasons. You can mine big volumes of data, you can get accurate outputs, and we don't need to worry about the balancing of data and the training accuracy when we got very large volumes of data into our training sets. And I noticed that rather than working with random forest or a linear regression model, I find neural nets very effective with very large volumes of data. So I thought I might take one example to calibrate your thought process throughout this hackathon, is how did we apply AI in a government division to improve citizen outcomes? And the area I'm going to look at, and I think Jeff mentioned this earlier on, is health. When we apply AI frameworks to health, we get better outcomes for the citizen. How does this impact the citizen from the application of AI in health? And I thought I might talk through these use cases. This is really, really important in the health scenario. Remember, this can be applied in any scenario, whether you're applying it to a bank, whether you're applying it to any type of division or marketing division, and you get the similar outcomes. Firstly, when we are thinking about the application of AI, it's really, really important to look at what are the use cases. We need to look at the rich single source of data. We need to look at on-device information processing, and we need to look at what kind of values we're going to extract from this. Now, to apply AI in health, I'm going to look at these 4 areas: empower and engage, efficient healthcare and communication. How do we accelerate our research? And a lot of the work we're doing today is around research. And what is our catalyst for innovation? I'm going to start off with empower and engage. When we look at this area, specifically in health, there are specific areas around personalized advice and informed decisions, improving health and wellness outcomes. These are the end results that you would expect from that AI modeling use case. Simplifying health transactions for claims and onboarding. For example, you go to a hospital today, you're a new patient, or you go to a doctor's surgery, you've got to fill out this form. Can we do it electronically? Can we do it quicker and faster? And can we access that information to improve and look at your history before a physician actually analyzes your health outcomes? We then look at efficient healthcare and communication. Can AI enable new models of care and care pathways? And I'll take a very good example, some of the work I've done in a larger hospital where we've used AI to detect high-risk cardiac patients. We can look at a number of variables in terms of AI, and then can we predict whether a patient is high risk, and then take the necessary measures in terms of diagnosis. Can we look at mole? Can we look at skin lesions and look and detect whether there is potential of cancer forming around these lesions? And there's a whole range of models of care where we can look at pathways to better improve health. We also need to understand lifestyle behaviors and a broader focus around data and looking at, are there alternative sources that we could merge together to understand the behavior, whether we're extracting health data off an Apple Watch and merging that with your patient records and provide a better health outcome. When we get into the accelerated research, is there faster approvals? Are there ways we can understand a patient's behavior? Can we monitor the effectiveness of a drug and try to find cures easier? So that accelerated research process is going to be absolutely critical. And how do we innovate? Now that we've got this data, can we find faster routes to market? Can we simplify? Can we detect patients quicker and faster? Can we reduce complexity throughout this entire process? With data architectures, it's absolutely important for us to understand how do we actually go about deriving these use cases. Now, I'm going to talk a little bit about data architecture. And in this example, I want to talk about relational architecture versus graph theory and why this is important for us today. So if you look at this example here, I'm looking at a typical customer. It could be a banking customer. And this customer, for example, they are Michael, Maria, Rashika, Jamie, and Elia. And what we want to look at is these customers may have multiple accounts or might have joint accounts, like Michael and Maria and Jamie and Elia. And you notice here, they might have multiple loan accounts. But what I'm actually looking at when I look at relational theory is I'm recording information in a database, in a table format. And my understanding from this, I noticed that Michael and Maria have similar accounts. And I've noticed that Jamie and Elia have similar loan accounts. Now, can I find a better way to model this data rather than putting it in a relational database whereby we can then take better advantage of the relationships in the data? So where I'm getting at is when you are modeling your data is, can I find alternative ways to build relationships between data? And if we want to model this customer account, it's a very typical scenario where you have customers in a database where you record customer names, you have account details, where customer 0 has account ID, it might have multiple accounts, and that same customer might have multiple credit cards, and that customer will have multiple loans. And this is a very common table structure we've noticed that exist out in the market today, whether you're in marketing, whether you're in health, whether you're in government, we use the relational table structure and we create these formats. Where I'm getting to next is, can we extend this relational theory? Can we understand how Michael, for example, owes, which is customer 0, owes loans, for example, loan 32, and how is that linked together? Where I'm getting at is, can we build some level of relationship within the data? Now, with standard relational theory, we have joins, we have customers where we can join various tables. For example, Michael, who is customer 0, owes, which is customer 0, account number 14. That means he owns an account. Or Michael may own a loan. So what I'm trying to create is some type of relationship that exists between the customers. And as you can see, it's fairly difficult in a flat table structure to achieve this. So when you're modeling data, it's always good to see if relationships exist in your data. And if relationships exist in your data, how then can you treat that data? And this is where it brings us to graph theory. This is a much more intuitive way where we see a customer owes to a loan. So a customer may have taken out a loan with a bank, and that customer owes that loan or has to pay back that loan. Or a customer owns an account, for example, or a customer uses a credit card. In using graph theory, we can actually build what we call relationships. The circles, as it's denoted here, are called vertices. The O's or the owns or the users are called edges. And as you notice, the loan, the credit card on account are vertices. And you might refer them to nodes, but they are vertices. in a graph situation or in graph theory, we can build better relationships in our data compared to a relational database. And if you think there are relationships between data, it's better off model in graph theory because it allows you then to form a more clearer picture of the world you're modeling your data in. Now, what you notice here is customer Michael. He uses his credit card. He owes to this loan, but they also Michael and Maria also has a joint account as well, where Michael owns this account and Maria owns this account. So utilizing graph theory, you can better model your data. And this is really important because if you understand the modeling parameters that exist between your nodes and your customers and your accounts, you can better represent that data. How much easier would it become is, I would like to offer Michael a new loan, okay? But if I understand Michael's scenario or Maria's scenario from a modeling perspective, I know Michael has a credit card, I know Michael has a loan, I know he has a joint account with Maria. I can better offer products to Michael. And this graph theory can be applied in health, can be applied in transport. So it's important to better understand or model your data so that you as an individual understand the relationships that exist. Now that we understand the relationships, we can better predict. So let's look at this scenario. This customer owes to this loan, it uses a credit card and it owns an account. That account then has multiple transactions in it. It withdraws from account, it deposits into the account. So you can have a transaction relationship with account. So now you can start building the larger picture. Can I detect this customer's spending to allow them more credit or to allow them to buy a new home? By understanding the relationships that exist with this customer between the loan, the credit card, the transaction, and the account, you can better serve this customer. Or understand where I understand that this customer spends regularly at this cafe and so on, and suddenly there's a transaction that may not appear that's based on the customer, the usual spending habits. Can I detect fraud in this transaction? Or someone may have used this customer's account, or you may have charged that account twice when you should, usually from behaviors where that customer might only spend for example, in that cafe, may buy the usual coffee and toast or might invite friends. But I noticed that 3 minutes later, the same transaction has been charged twice in there. It may not be fraud, it might be an error, so you can refund that customer. So understanding nature of behaviors using graph theory are going to be absolutely critical in building relationships to then model that data. For example, I like to predict, what will the customer do next in terms of his spending patterns? Does the customer has enough cash flow for the month? Are they good customers in terms of managing their funds much easier? And can they pay back the loans or the credit cards they've taken out? And if I do increase the credit card limit, do I understand the customer's behavior enough to increase that credit card to that specific limit? Modeling your data utilizing graph theory through relationships and edges, you'll find will provide a better outcome in terms of your predictions. So if I want to predict whether a transaction is fraudulent or not, or whether a transaction is accurate in terms of their spending patterns, then I can do that much easier utilizing graph theory than a standard relational database. So it's really important to understand that graph theory works when there's relationships between your data. And if we look at our world today, whether it's a social media, am I an influencer in my network, relationships form a very critical part of modeling. And if I can build relationships in my data, I can then utilize those relationships to then predict more accurately. I want to talk a little bit about strategy and explainable AI, because I think this is really important when you're building out your use cases today. I spoke about relational databases, I spoke about graph theory, about understanding relationships in your data. I think it's really important to define what are the use cases you want to build out today, or or in future? What is your data strategy? How do we mitigate some of the risk factors when we are building out this model? And then what is the team you're putting together today to achieve this? You need to look at the whole project management strategy and understanding your use case. You then need to look at your frameworks. What AI framework am I going to use today? Is it repeatable? Are the inputs or the data inputs well defined? Do they follow some level of data governance principles? Are the outputs you're getting from the predictions, is it well described and explainable? So if you go and train a model today and you're getting these outputs, what are your actual outputs? Are the model well defined? Is the model accurate in terms of its outputs, whether you're using a confusion matrix or you're using receiver operational characteristics, etc.? Are the model accurate? Are there any improvements to your predictions? Now, to get your improvements to your predictions, usually, you look at your modeling techniques, but more importantly, do you have enough data to get that level of accuracy? And then from an outcome perspective, can I explain my predictions? Can I develop the level of assurances that this model is operating at and provide the accurate predictions? And is the methodology repeatable? If I rerun these methods, are you always going to get the same outputs each time utilizing the techniques you are? So it's really important to look at the AI framework and thinking. I think it's going to be critical for your outputs in terms of your use cases. Now, I want to talk a little bit about the tooling that we are doing today at the Public Sector Consulting, or more importantly, Brew AI tooling. Brew AI is a company that I've developed that does a lot of research and development around the automation of AI. So what we're doing today is, for all the data inputs you feed into the model, it will automatically build you a commercial grade deep learning model that will provide very consistent outputs. And I thought I might talk a little bit about the architecture, and it might allow you to think a bit more how you develop these models. With Brew AI architecture today, when you feed Brew AI an Excel spreadsheet or around predictions, Brew will automatically go and detect whether the inputs, text, categorical, numeric, binary, images, audio, etc., and automatically code it for you utilizing the Brew AI engine. So from a user perspective, you can feed it an Excel spreadsheet and it will automatically build you out a commercial grade deep learning model. And it will encode the data and then it will decode the data and give you that output. So this is how Brew AI architecture works today. I might also quickly talk about some of the examples you could use. Just assume you are predicting whether a patient is high risk or not. Okay, so you might pass in some text, some numerical values, some binary values, some images. The engine will then process it and then will output a categorical variable where to say that this patient is high risk or not. Or you might push it through the engine and you want to predict the blood pressure level of this patient, and you can predict out using a numerical value whether I want to predict out the blood pressure. So the Brew AI architecture is really flexible and it can ingest a vast amount of data and it can produce an output. What's really important in this entire thing, you have an audit trail and you have an explainable output. And you can view this today at brewai.com, where you can look at some of the features of this tooling which we are taking out to market today. I want to talk a little bit more about how Brew AI features work and why it's important today. Brew AI is a no-coding tool set. It builds commercial-grade deep learning models for all area of government agencies and business with an embedded explainable AI framework for auditability. What's really important here is the scientist today focuses on the data architecture, like I've explained, and the outputs, rather than bothering about developing deep learning models to get you that output. You can tune your deep learning models, you can tune your data sets, you can tune your data architecture to get you those accurate predictions. And I think that's really important today in terms of automation, to get scientists to really not worry about cleansing the data or detecting what data type it is, but to model the data so you get a lot more accurate outcomes. So, Brew AI extracts data from multiple sources, and we can use scripts to automate this. It will then train an AI engine to optimize the engine. So Brew AI has an automated does automated training of algorithms, and predictions could be embedded as simple as supplying a spreadsheet. And all inputs gives you a consistent output by understanding the algorithms, methodologies, and bias in the data set. And Brew AI can provide the necessary audit trails. We've been consistently doing a lot of research and development in Brew AI today, with feature sets like embedding AI in databases and utilizing SQL queries to predict and train models. So throughout your model development today, look at your data, look at your explainable AI, and look at your outputs. It's going to be absolutely critical in your development of models as you go forward. So that's a lot about Brew AI, and I thought I might move into the next part is around use cases. I've taken this use case around ransomware detection, and this will allow you to think about your use cases and what you are actually trying to do today. In terms of ransomware detection, you need to think about the data attributes that goes into this detection or malicious use case, whether I'm predicting a website is malicious or not, or might have JavaScript code that can be used to actually inject a malicious behavior when you're browsing it into your browser onto your desktop. And I think it's really important is thinking about the data inputs that goes into your use cases, because I spoke a lot today about health, I spoke about banking, and now I'm speaking about malicious detection and ransomware detection. So it's important to think about the data inputs that goes into these modeling behaviors, which are going to be absolutely key for your outputs. Here, I'm looking at what are the key attributes from a website you are browsing can be used to detect whether this website is malicious or benign, if it's a malicious website. You can look at the JavaScript code, you can look at the URL, you can look at the raw page content, and then you can predict whether you're using a deep learning model to say, I think this website is malicious because these are the attributes that that impact it. And for you to build this malicious ransomware detection tool, you need to analyze what is your data set that you are going to use. What are the key values? You've got to look at things like missing values. Is it balanced? What methods are we going to look for the output? How can we get quicker predictions? Can we build an explainable AI model? What are the data inputs? You could use IP addressing, JavaScript code on the website, page load times. You could look at the the address, the registrar information. So these are all your data inputs. Having it cleansed, having it then modeled and predicted output will then allow you to detect whether that website is malicious or not. So looking at all these use cases, I thought I might talk about the data points on this website, which will allow you to detect whether it's positive or negative, whether it's malicious or benign. When you're analyzing a website, I think it's really important to look at the IP address of the website, the geolocation, the length of the URL, the length of the JavaScript code, the length of the obfuscated JavaScript code, the top-level domain name, the who is of the domain information, and whether the site uses HTTPS or HTTP, and then I want to predict whether this website is positive or negative, malicious or benign. My data points or my attributes are the ones that are going to allow me to predict whether it's positive or negative. So the first thing you should do in your use case is, once you've defined your use case, in this case, I'm detecting a website is malicious or not, define your data points and have an explanation for your data points and how you got there. So you're starting with that explainable AI framework and you're moving towards getting an accurate model. So I talked about modeling in various domains that will help you with your thought process today. I talked about extracting data from sources, training and optimizing the engine, and drawing on technical expertise, and then producing a report. as Steve spoke about, the PowerPoint presentation that best explain your entire process throughout this entire journey. I hope this provides a good understanding or thought process, and I wish everyone the very best in this hackathon. So do look me up. If you want to, I'm on LinkedIn, or you can email me at gavin@publicsector.consulting if you'd like to talk further, or drop me a message in the chat, and I'm happy to help. Thank you very much.